Good morning, everyone. Thank you so much for joining our webinar this morning. The topic of creating an electrically safe work condition. Today I have here with me Charlie Miller. Charlie is going to be the primary presenter, and I will be just adding, I'll be talking about our permanent electrical safety devices, voltage indicators, and safe test points on how they comply or meet Article 120.5. which is the process for establishing and creating an electrically safe work condition. Again, all the discussions will be of the opinions of Charlie Miller and I only, because Charlie also represents NFPA 70E technical committee, and these are not anything from their opinion. It's just purely his personal opinion of all the subject we'll be discussing today. With that, I will turn it over to Charlie, and please remember to type in your questions as you're going through the webinar using the webinar console, and then we'll try to answer them at the end. This should take about 40 to 45 minutes, and the entire discussion will be around Article 120.5 within the 70E only. Thank you. Thank you, Charlie. Just go ahead, please.
Good morning, and hello from Lebanon, Tennessee, located 30 minutes east of Nashville, Tennessee. Lebanon is the home of Cracker Barrel. Most people have heard of Cracker Barrel. All right, so our objectives is to recall the definition of electrically safe work condition, which in NFPA 70E there is a definition. We're going to talk about that. We're going to explain the 7 or 8 steps. There's really 8 steps, but the step number 8 is typically for medium and high voltage. And then we're going to summarize the process of testing for the absence of voltage, which is a big part. It's only one step in the 8 steps, but it's a big part of the of those 7 steps. All right, the definition of a qualified person. Let's talk about that at first. 70E has a definition, OSHA has a definition, the National Electrical Code has a definition. They're all very similar, but this is what 70E says. It says it's a person who has demonstrated skills and knowledge that's related to the construction and operation of electrical equipment and installations, and that person has received safety training to identify the hazards, which in that way they can reduce the associated risk. The pictures we have, most of them are from training that I have given, and this is, we were doing hands-on training the day after the classroom training, and this is Pawtucket, Rhode Island, just outside of Providence. All right, here's the definition of electrically safe work condition. It's a state in which electrical conductors and circuit parts have been, first of all, disconnected from energized parts. They've been locked and tagged in accordance with established standards. Now, a lot of places, a lot of industrial factories and plants, I've taught and I teach in quite a few plants here and there. And if a plant does nothing else, typically they at least have a lockout tagout program. But lockout tagout is only one step in establishing and verifying an electrically safe work condition. Now, the third one is the third part of this is testing to verify the absence of voltage, to make sure there is no voltage there, and we have specific steps in testing for the absence of voltage. And the last one, if necessary, we're going to use temporary electrical safety grounds for personal protection. All right, here are the 8 steps. Determine all electrical sources, and I'm just going to go over these quick because we're going to spend a little bit more time on each one. We're going to open the disconnects. We're going to visually verify if it is possible. It's not always possible. We're going to release stored electrical energy. We're going to block or relieve stored non-electrical energy. It used to say mechanical energy. The committee, this changed in the last edition from mechanical to non-electrical. We're going to apply lockout, tagout devices. We're going to test for the absence of voltage, and if necessary, we're going to put on temporary electrical safety grounds. Now, this is set in 70E, this is section 120.5, And our 7 or our 8 steps are in this section 120.5. All right, the first one, determine all possible sources of electrical supply to the specific equipment. How do we do that? We are to check applicable up-to-date drawings, diagrams, and identification tags. Try not to laugh too hard when I mention checking up-to-date. A lot of places don't have up-to-date any of that. And so, all right, so if we look on a panel schedule, we see a breaker, or we see in a motor control center, we see the bucket that's labeled for the motor that we want to shut off. So we turn it off either on the regular breaker, we turn it off in the MCC bucket disconnect. So after we turn that off, can we trust our life that that is labeled correctly? And I see everybody, well, I don't see you, but I know you're shaking your head. No, you cannot, you do not trust your life to labeling. But it's a great place to start. It's at least it's a great place to start. All right, number 2, open the disconnects. After properly interrupting the load current, open the disconnecting device for each source. I don't know if you're familiar with my work. I used to write a magazine article, an electrical contractor magazine, for 19 years called The Code and Focus, where I did the writing and also I did the illustrations in my books. I also do my own illustrations, and I started this in 1999 with the first illustrated guide to the National Electrical Code book that I wrote. And so I thought, if I'm going to draw my own equipment and do my own drawings, I'm going to make it my own brand. And I know I'm sure you have heard of Square D, right? But you may not have heard of Square M. It is the Miller brand. It is the Cadillac of equipment. So this, I've got a disconnect here. It is the Miller brand disconnect. But what is talking about load current? Old disconnects, you could pull up the handle and turn it on as slow as possible or off as slow as possible. But typically disconnects now are spring loaded, or a lot of them. The smaller ones are still not, but a lot of the bigger ones are 100 amp or more, or maybe even more bigger than that, are spring loaded, where it kicks in, pulls the blades in very fast and pulls the blades out very fast. And so this is what it's talking about, load current rated. Not all disconnects are not load current rated. 120.5, number 3, visually verify. If it is possible, visually verify that the blades of the disconnecting device, safety switch or disconnect switch, are fully open, or if it's a draw out type circuit breaker, make sure that it is withdrawn to the test or fully disconnected position. Now, in where it says 2021 here, and the words test or are bold, that was added in the 2021 edition of 70E. Before that, it just said make sure that it's withdrawn to the fully disconnected position. So I'm in my presentation, I'll show you what has changed from the 2018 to the 2021 edition of 70E. All right, so here's an example. We open the disconnect or safety switch. We see that all 3 blades in this case are fully withdrawn. They're not connected. Or here's an example of of switch gear with a rack in, rack out type draw in, draw out type circuit breaker. And besides it saying open, we also know that it's not able to connect because it is right at the door. Because when it's able to connect, it's typically 18 to 24 inches inside the cabinet, inside the front of the door. Now this switch gear, this one has a window. Not all switch gear, not all breakers like this have windows in them, but this was easy to see, especially easy to see that it says open. Well, why do we do this? I've taught a lot of classes, and this when I'm covering NFPA 70E for the classroom portion, we talk about this. We talk about if it is possible, we visually verify that all the blades are pulled out or the draw-out type circuit breaker is close to the front. It's fully withdrawn. I don't remember seeing myself like this where one blade is still attached, but I've talked to a lot of people who have seen, a lot of electricians and maintenance people who have seen one, two, or all three blades still attached once the disconnect handle was pulled down into the off position. So this is, now if it's possible, well, a regular circuit breaker, can we, even if we have the panel cover off, we turn off the breaker, can you tell that the contacts are separated in a regular circuit breaker? No, you can't tell that. So this is the reason it says wherever possible. If it is possible, visually verify. It may not be possible, but this absolutely, every one of these steps are extremely important. And so just remember to add this in to the steps of putting electrical equipment into an electrically safe work condition. Number 4, release stored electrical energy. In this, number 4 and 5 were added a couple of editions back, not this edition, they were added last time. But number 4 and 5 were always part of lockout, tagout anyway. Release stored electrical energy. Stored electrical energy that might endanger personnel have to be released, capacitors have to be discharged, and high capacitance elements, elements shall be short circuited and grounded if the stored electric energy might endanger personnel. It's just this, I've got just a air conditioner compressor capacitor, and typically you're going to, for small loads like this, small capacitors, you'll just take a screwdriver and touch on the contact points to discharge it. Has anyone ever gotten bit by a capacitor? I absolutely have, and a lot of people have, and it's just like you're getting shocked or regular shock. So it hurts. So it's a great thing to do. All right, number 5. It was, and I mentioned this a few minutes ago, stored non-electrical energy, and in 2021 it was changed from stored mechanical energy to non-electrical. Block release stored non-electrical energy in devices so that the circuit parts cannot be unintentionally energized by such devices. Some examples would be stored non-electric energy would be springs, elevated machine members, rotating flywheels, hydraulic systems, air, gas, steam, water pressure, etc. Well, how are we going to dissipate these? Well, you're going to have to figure out that, and you should have, with equipment, you should have designated probably a sheet for lockout, tagout. Dissipating restraining methods might include repositioning, blocking down bleeding, etc. Then number 6 is apply lockout, tagout devices in accordance with a documented and established procedure. All right, so this is not in 70E. This is more, it's in OSHA, but it's more of a, just like if someone is non-electrical, if someone's not getting into the electrical, they are supposed to, if they're just doing regular lockout, tagout, they're supposed to attempt to operate the equipment. It's not in 70E, but I like adding this in. All right, so a task qualified person shall attempt to operate the equipment, operating controls, or otherwise verify the equipment cannot be restarted. I teach a lot of classroom seminars, and a lot of places want an additional maybe half a day for hands-on training with their live equipment. And with the hands-on training for, besides the live equipment, we'll put a piece of equipment into an electrically safe work condition, or I'll have the workers, the qualified workers, put the equipment into an electrically safe work condition. And sometimes I've used in industrial plants, I've used an electric overhead garage door. Well, once we shut off the disconnect or turn off the breaker, lock it out, tag it out, then someone will attempt to operate the control to raise or lower the electric garage door. And so it's just one additional little step. I like adding this in. It's not in 70E, but what's it going to hurt to try to start the equipment anyway? All right, number 7, voltage testing. We are to use an adequately rated portable test instrument to test each phase conductor or circuit part. It used to say to verify it is de-energized. In the 2021 edition, the wording changed. We test each phase conductor or circuit part to test for the absence of voltage, because this is what is being done. We are testing that there is no voltage there. Well, how do we do this? It goes on to tell us we test each phase conductor or circuit part. We do it phase to phase and phase to ground. So if it's 3-phase, we're testing A to B, A to C, B to C, and then A to ground, B to ground, and C to ground. In 110.8a, this in a different section. Now, remember, our steps are in 120, but this is 110. I wanted to bring this up. Only qualified persons shall perform tasks such as testing, troubleshooting, and voltage measuring on electrical equipment where an electrical hazard exists. So in this part, the person doing the voltage testing for absence of voltage, has to be a qualified person. Now, all right, so what if the person is not a qualified person when they're doing the training? Well, that's okay. If someone is undergoing training and they're being supervised in this training, then they can do this testing because they're being supervised by a qualified person. All right, before and after the test, we have to make sure that the test instrument, typically electricians, we typically call it voltage detectors, but the technically correct name is test instrument. Before the test, we have to make sure the test instrument is working properly by using it or verifying it on any known voltage source. Now, it used to say, it didn't change in this edition, it changed in 1 or 2 editions back. It used to say we verify on a known voltage source, but now it says any known voltage source. So you could, and it doesn't have to be the same voltage. So maybe you're going to be disconnecting power to a 480 volt 3-phase motor. We can check it on a 120 volt source. It just says any known voltage source. You could check it on a battery. You could check your meter on a 9 volt battery, a AA battery, on any known voltage source. Now, what is not correct is to put it over in continuity and check the continuity part. No, we've got to be checking the voltage, the voltage of the meter. And so it doesn't have to, because it says any known voltage source, it does not have to be AC if you're going to be disconnecting AC, or DC if you're going to be disconnecting DC. But I caution against having most meters, a multimeter, check a battery and then check an alternating current load. And because most multimeters, you have to change it to DC to AC, back to DC, and if someone forgets part of that, then they may not get a true reading for testing for the absence of voltage. Now, the meter I have in this picture, the one that this is a Fluke meter. Fluke absolutely makes great products. T61000. Now, this meter happens to have one dial setting for both DC and AC. So it wouldn't be as much of a problem checking a DC battery source. All right, we have to check our meter before testing for the absence of voltage. Then after we check for the absence of voltage, phase to phase and phase to ground, we have to test our meter again. Fluke makes a device, it's called a proving unit, and this is it's a great little device. There's 4 AA batteries that go in here, and you're seeing on here it's about 204, somewhere around 240 volts that it puts out. It has a switch on the side for AC and DC. All right, so testing for the absence of voltage, we have to make sure our portable meter is working correctly on any known voltage source before we test for the absence of voltage. All right, then we test each phase conductor or circuit part phase to phase, and you're right, phase to ground, phase to phase and phase to ground. Then after we test the phase to phase and phase to ground, we have to test our meter, like we call it typically voltage detectors. Test instrument is the correct name. And so we test our meter again to make sure it is working. You may have heard the term live, dead, live. I like that term. It's not in 70E. I like that term because if you can remember that, it's easier to catch that last testing the meter. Because a lot of times, and I see this quite often when I'm doing hands-on training, someone will test the meter, they'll test for the absence of voltage, and bingo, they're done. Well, wait. And if they happen to look at me and they'll go, oh, and they'll remember at that point going, oh, I gotta test the meter again. Now this was done, I took these pictures a few years ago, and this was in South Carolina. And now it looks like one hand has the meter above and one hand the below is testing on the meter. No, his right hand was actually either coming up to the proving unit or coming down from the proving unit. So it doesn't, one probe is not on the above meter, one is not on, it's not on each meter there. All right, there's an exception in the testing for the absence of voltage. And what this exception says, and there was a little change in the 2021 edition, and it just changed the wording to an absence of voltage tester, which is exactly what the device is. This device, and there's a couple of them out now, and the device it goes on to equipment, but the device has to do everything we have to do, and that's what this slide and this slide tell us. It has to do everything we would have to do if we're in front of the equipment, meaning that it has to test itself on any known voltage source. It has to test phase to phase and phase to ground. Then it has to test itself on any known voltage source. Now these devices, you may have seen these, you may have seen the pucks, the Grace pucks, and they're on a lot of equipment and industrial equipment. These devices are not meant for, they don't do absence of voltage testing. They are great in that electrician or maintenance person is walking around a plant. They can look over and see that power of phase A, B, C, phase 1, 2, 3, that all 3 phases are on, and some of them also show the ground. They are great, but these devices, that are up on the screen now are just indicator lights. They're voltage indicator to show you that there is all three phases, and sometimes the ground as well. This is another option that Grace has.
Charlie, do you want me to just make a quick comment on the previous slide, if you don't mind? Just go to the previous slide.
Yes.
So just want to reiterate the points, like Charlie mentioned a few things about Article 120.5, whereas in step 3, he talked about visually verifying the blades, and also there is a step 4, which is a release of stored energy. So these devices, as he was trying to point out, I want to make a comment that these devices can be used to visually verify the voltage presence that meets with step 3 and step 4. For example, there are disconnect switches where you have a visible blade where you can see through the window the status of the disconnect switch. If you don't have in your legacy equipment, you can install these devices where if the blade got stuck, when these devices are wired, this will give you a flashing light outside the door. And again, these devices are meant only for task qualified persons or unqualified persons per 70E definition. This is not meant for absence of voltage testing. That's why I want to make it very clear. There's a lot of confusion around the industry that these devices are for visual voltage presence verification only. And then this can be used by task qualified persons like your mechanical operator or the one who is performing the secondary side of the equipment maintenance, meaning someone who is turning the disconnect off and doing a bump test and verifying or working on the secondary side of a pump, not touching the electrical circuit parts or components. Thanks, Charlie.
All right, this is another option. I like this option. What this option is really a remote test point. This can be installed on the door. It can be installed on a fixed panel that is not open and closed all the time. This can be installed in a junction box right beside the equipment. And what this option is called, Grace calls it a safe test point. And we can use this to test for the absence of voltage outside of the cabinet before ever opening the cabinet up. And in this, you are doing the testing yourself, meaning you're using your own meter. You are testing your meter to make sure it's operating properly through verification on any known voltage source. Then from outside the cabinet, you are testing phase to phase and phase to ground. Then you're testing your meter on any known voltage source. And if it's installed properly, of course, regardless of the device, it has to be installed in accordance with the instructions. And so this is just more a remote testing. And if it's done, if it's installed properly, you're doing the testing properly from the outside. You know the cabinet, if it's installed on the line side, you know the cabinet is electrically safe after doing this. All right, so here is, this was in Laurel, Mississippi. This is Grace's voltage test station, which has the safe test point inside. Now on this, this was a water pumping station in Laurel, Mississippi. We were doing hands-on training. The disconnect was on the outside of the building. We turned off the disconnect. We visually verified the blades were out. It did all of the steps, and then we went inside and the cabinet is closed. And so you see the person's not wearing a hard hat face shield, not wearing gloves, because the safe test point is just like it says, it is incredibly safe. And so it'd be like testing a receptacle. Your contact points are recessed in there. They also have impedance built in that even if you were to touch the blades of the meter, the blades, and I've seen this done where they put a paper clip in from one to the other, and it did not short it out because of the built-in impedance. And so what this guy did, he tested the meter, tested for the absence of voltage, tested the meter again, and the cabinet could be opened at that time without wearing shock and arc-rated PPE. This is the combination unit that I mentioned that Grace has. It has both the puck, the lights on it, and the safe test point, and is and I've shown this on a lot of places. A lot of people very much like this. All right, let's go on with this voltage testing. Can we use a non-contact type of voltage detector as the only method to test for the absence of voltage? And the answer is no. And I'm sure you were shaking your head as well. How are we supposed to test for the absence of voltage? Well, with a voltage stick like this, a non-contact, you could test it on something live before and after testing, but this cannot test phase to phase and phase to ground. So it cannot be used as the only method. Can it be used as a first line of defense? I don't have a problem with that. Some electricians and maintenance people won't even carry these around, but that's as a first line of defense. I don't see a problem with that as long as all of the steps are taken, and this is not used to test. Of course, it cannot test phase to phase and phase to ground.
So Charlie, one quick thing here. So Grace also makes a product that will work with this non-contact voltage detector pens. Those are called voltage portals. Those are yellow in color. Again, these are used only by task qualified person, not a qualified electrical worker. And these cannot be used for absence of voltage testing, period. So safe test point, which Charlie mentioned before in previous slides, those are built into the high impedance protected circuit. You can safely verify the voltage absence from outside the door without getting a max fault beyond 3.5 milliamps. Your max exposure, even if you put accidentally a paper clip and short it together, will not exceed 3.5 milliamps. Again, these are all listed and labeled by UL for 61010 standards. That is a measurement, testing, and signal generating equipment, which is same as your voltmeters or your fluke meters, which Charlie showed in previous slides. So please don't confuse this device. What we're showing on the screen are not meant for absence of voltage testing. And this is only used for enhanced mechanical lockout tagout for task qualified personnel. Thanks, Charlie.
All right, so several editions back, this type of tick tracer was a medium and high voltage tester was not even in 7E. Finally, it was added in. It says on electrical systems over 1,000 volts, non-contact capacitive test instruments are permitted to be used to test each phase conductor. Now, the change in the 2021 edition, they added, well, I'm on the 7E committee, so I guess I can say we added capacitive to this section. All right, here's step number 8, and this is typically not done on less than 1,000 volts. These are temporary electrical safety grounds where the possibility of induced voltages or stored electric energy exists. Ground off circuit conductors, circuit parts before touching them. Ensure the grounds are removed before re-energizing. Absolutely. All right, until you have put the equipment into an electrically safe work condition, which meaning establish and verify, then the circuit conductors and circuit parts are not considered to be electrically safe until all the requirements of Article 120 have been met. Well, what is Article 120 in 7E? Article 120 covers lockout, tagout, and the process of establishing and verifying an electrically safe work condition. And until the equipment is in an electrically safe work condition, you have to use safe work practices that's applicable to the circuit voltage and energy level and in accordance with Article 110 and 130 until that electrical equipment is in an electrically safe work condition. Now, if you're looking at me on this saying, oh, wait a minute, why is his shield up? I am outside, well outside the arc flash boundary, watching this, working with this a maintenance person doing hands-on testing. After an electrically safe work condition is established and verified, it is safe to work on equipment without wearing shock and arc-rated PPE. This is that water company in Laurel, Mississippi. I go down there every 1 to 2 years. And so we had just gone through hands-on training there. Protective clothing and equipment must have a rating equal to or higher than the prospective incident energy exposure. And arc rating is the value that defines clothing and equipment to protect against arc flash, either ATPV, arc thermal performance value, or E sub BT, energy of break open threshold. The picture is Terry Becker, our friend that sometimes does webinars with Grace, and sometimes we've been on the same one answering questions. And this is Oberon 40 cal suit. It's a great suit. And if you notice, the shield is clear. They call it true color gray, and it's wonderful. It's not so dark, and also it doesn't change the color of things. Now, in electrical, we don't ever need to know the color of anything, do we? Well, of course we do. Is it a yellow wire? Is it a green wire? Is it a white wire? So absolutely, when Oberon were the first to come out with this, it is great to be able to see through the shield. All right, so in the new edition of 70E will be out in 2024. Typically, it's going to be out in probably September of 2023. At this point, it has gone through, we've had our first draft meeting, and this is proposed new text for 2024. And I know the reason, and absolutely the reason that Bhanu said that these are his opinion and my opinion is I think this new wording is going to cause more problem than good. Here's what they're wanting, and here's what's been added right now. And we're in the first draft stage right now. So it was a public input that was added, and the committee accepted this. Well, they added the word each, but as a user or anybody, if you like this, you can either comment on it in a good way. I think a lot more people are not going to like this. Let me show you. Here's what the new wording is going to say. Use an adequately rated portable test instrument to test each phase conductor or circuit part at each point of work to test for the absence of voltage. All right, well, first glance, it sounds good, but there is no definition of, well, what does point of work mean? All right, I see this, and what this means, all right, in a cabinet, you turn the disconnect off for the whole cabinet, and typically it's the upper right corner, and you turn it off, you maybe even lock it out, you turn it off before it gets there. On the line side, you open the cabinet up, you're what I call dressed out, you have shock protection, arc flash protection, and you test your meter, test for the absence of voltage at the top, and then test your meter again. Then you could take off your PPE and work on or do anything in, because the equipment is in an electrically safe work condition, as long as you've gone through all the 7 or 8 steps necessary. Well, because of what it says at each point of work, that means, I feel like what that means is on the line side of every component in that cabinet, you would have to stay dressed up and test everything, each and every component in there. All right, let me give you another example that kind of gets even a lot worse. You've got a building that is being all the equipment is being taken out of it. It was an industrial plant. The service coming in on the outside has been disconnected. Normally, you would check even at that point before, or even right now, check the line side, and then and put that line side and the disconnect there. Everything would be electrically safe inside the building. With this new wording, someone is going to have to be dressed up, suited up, and test every disconnect, every conductor, everything in that building, even though that it's been disconnected on the outside. And absolutely, it is important to test where you're working. But this new wording, I'm just personally, I don't like it. Now, again, I'm on the committee. I can vote against it, but I'm 1 out of 25. So we'd like to hear what your ideas might be for this new wording. Bhanu?
Thanks, Charlie. I mean, I asked Charlie to specifically talk about this point in detail because it's going to make it very difficult for the people who are working in the industry to don on a complete PPE and go and test for absence of voltage at each point of work. As Charlie mentioned, you can take an example of industrial control panel, which is generally used by most industries, right? So they have this 600 volts or a 480 volts incomer. They will disconnect it. They will verify the absence of voltage at the load side of the disconnect, and then they can keep working the other side of the equation. But what with this language tells you is, for the same panel, if you have a contactor or a thermal relay or any other component built in, you need to go and verify voltage at each point of work. That's going to be very cumbersome, and it's going to be very time consuming, and doesn't make sense. Because, I mean, even if you have a panel that has 2 feeders incoming, as long as you verify the 2 feeders are shut down and both are locked out, that's feeding this panel, everything downstream has been completely isolated and verified and put in a electrically safe work condition. There is no need for verifying at each point of work, right? So that's kind of where we're going with that. And again, these are open for the public comments, and please feel free to input your comments as this goes to a second draft meeting, and this will be very, very helpful as the committee makes a decision next year on this before this goes into effect. So thanks, Charlie.
Yeah, that's, you can tell I'm, do I want people to be safe? Do we want people to be safe? Absolutely. But part of being a qualified person is understanding where you need to test for the absence of voltage. I can see this being more difficult than good. And if someone doesn't know where to test for the absence of voltage, aren't they an unqualified person? Because a qualified person would know where to test. And so if someone turns off, okay, and probably the idea from this came that, all right, someone turns off a disconnect switch in a MCC, a motor control center bucket, and they test it on the load side of the disconnect switch that goes out to a motor. Well, and at that point, I would want power to be checked, or the absence of voltage to be checked at the motor. And not all motors remote that are far away, not all of them have a disconnect switch within sight of the motor, because the National Electrical Code says that if it has to be inside of the motor unless the disconnect switch can be locked in the off position. And so I just see this being a bit of a problem there. Now, when I don't know if this is, I don't think it's made it out where you're going to be able to see this first draft yet, but when it does, take a look. You'll have a little bit of time, not much. You'll have a little bit of time to make a comment and what you feel, if this is good or this is bad.
So Charlie, do you want to just talk a few things about how it will affect basically if any door mounted device is used, right? So actually the intent of the person who has put the public input was primarily to ensure that the door-mounted devices cannot be used for absence of voltage testing. But when you put each point of work, what it means is, even if you verify the absence of voltage from outside the door with our device or a device using an exception, whichever it is, it's only verifying the absence of voltage at that given point, at that point of work. But when you open the cabinet, it's only verifying to where it's connected to. But other than that, still you need to go and verify the absence of voltage at each point of work if you go on the same definition. So this is going to basically create a lot of chaos and a lot of unwanted, unnecessary work for the electricians in the field to don the PPE and verify the absence at each point of work. So just be mindful that you put your comments in.
I absolutely believe in devices that help make our lives safer. And there are devices out there that can do that. That can be where, like Grace's, you can check from the outside of the cabinet without opening it up to verify the absence of voltage. There are devices, absence of voltage testers, but with this new wording, then that's just the very line side of that breaker coming in the very top that's been tested. To be able to test, to be able to open the cabinet up, you're going to have one of those devices on every component in that cabinet. And I just see that I think that really does away with all of this great technology that we have out there, because a company's not going to buy 20 of those devices and put them on the line side of each component. Now,
hey, not that we don't want to sell more product, Charlie. Not that we don't want to sell more product. We'd love to sell 20 safe test points per bucket, so we'll be all good. I think so will be the competitors too. So
I like things that make our lives safer. We come a long ways over the years with 70E. As an electrician, when I first started out, we didn't do things electrically safe. In apprenticeship school, I was not taught electrical safety. I was taught, well, even way back then, if I could go back and tell my younger self some things to do or not do besides getting married the first time, I would tell myself to get a pair of rubber gloves with leather protectors rated for the voltage I was working on. Back then we weren't taught electrical safety. Now I'm saying back then, I went through apprenticeship school in 1978. And so we didn't, but we've come so far since then. We have rules and regulations. To me, this feels like we're stepping back and just we're getting rid of some of the technology that we're doing right now. And if my definition of a point of work is incorrect, I want there to be a definition in 70E to define what does that mean exactly, because point of work to me means the line side of each component. All right, things we've talked about, and then we can get to questions if there are any. We covered there are 8 steps in establishing and verifying an electrically safe work condition. Now, step number 8 is typically for over 1,000 volts. It's the temporary electrical safety grounds. Before and after testing for the absence of voltage, we have to make sure that the test instrument is working properly through verification on any known voltage source. If you can remember live, dead, live, that absolutely helps. Safe work practices that are applicable to the circuit voltage and energy level have to be used until such time that the electrical conductors and circuit parts are in what's defined as an electrically safe work condition. As far as I am, of course, I talk a lot. I've talked a bit more than Bhanu, but that's okay. To me, it's okay. Here's my name, my contact information. If you have questions, and you may have a 70E question, if you're wanting to talk to me about training, absolutely contact me. I travel all over the country. Last year, before the pandemic, I went to the country of Suriname. Everybody who knows where Suriname is, raise your hand. I don't, well, now Bhanu does, but he didn't before I went. Nobody knows. Suriname is South America. But anyway, let's, Bhanu, what have we got here?
So I think the first question, I think from John Marshelli, so he asked about what about a gas PVC pipe running at about 2 feet from the HVAC run with few motors on it with the electrical transformer on site. So you talked about different forms of energy, right? So when you talked about in the lockout, tagout, relieve the stored energy, where does this gas fit in, Charlie? It's other forms of energy is where the gas is.
Well, okay, I'm not, can you, what do you, what's your, I mean, I didn't quite understand the question.
So what about a gas PVC pipe running at about 2 feet from a HVAC with 250 horsepower motors in a rooftop condition and thousands of electrical and transformers on site? So the question is, clarify gas pipe at 2 feet from HVAC units.
All right. Now this is
code record.
If it's all closed system, it's not someone. I mean, what's going to have to be done is a risk assessment, and if this is not considered a risk by having the gas pipe there, then that's not a problem. If there is a potential risk, this needs to be part of lockout tagout, and that's understandable. What all needs to be done in lockout tagout is not only the electrical, but anything else that can cause harm or destruction. So that absolutely needs to be considered in lockout tagout and in part of a risk assessment.
Okay. So the next one is a comment from Sunny. So he says some companies approved this, which is a bump test you called about, the push to start to verify the equipment doesn't restart, for verifying voltage if the work is not electrical. So as I said, the bump test is not a requirement from 70E, but still I think it shows up in CFR, right, Charlie? It's there, the push to start to verify it's in a OSHA.
Well, where it comes from is really from regular lockout tagout, not electrical. If someone is just doing lockout tagout to change some parts on maybe a mold, and they're locking the equipment out, they're not getting into any part of the electrical system, then the bump test trying to start the equipment is part of regular lockout tagout, as long as there's no electrical involved. I like adding this on. It doesn't have to be added on when we do electrical, because we're covering everything anyway. But if it's easy to try to start the equipment by pushing a start button, then what's that going to take? Another 10, 15, 30 seconds or so? Again, it does. If you're doing all the steps for electrical lockout tagout, that bump test, that push to start, does not have to be done.
Correct. Okay. Thanks, Charlie. So is there a new definition for qualified electrical worker? I think the last change was in 2018, I guess, right? So when they said the person who is qualified shall also be able to address the risks and hazards as they may arise while performing the tasks. Correct, Charlie? Correct me if I'm wrong.
There's no, the wording gets changed around every once in a while. And like this time, it was just a little wording change. The grand overall meaning of a qualified person has not changed. The overall meaning for a qualified person in 70E, in the National Electrical Code, in an OSHA, is all the same. It's just the wording is a little bit different from document to document.
Okay. So So there was another question. So do safe test point may give us a false dead due to possibility of having a wire cut as well and requires maintenance as well. So this is a great question. We get this question asked several times. So one important point I would like to make here is, so these devices are all good. Any door mounted devices are only good to the point when you can verify it from when to verify the voltage is present to start with. For example, if you go in front of this device and verify the voltage presence to start with using a light test, then absolutely you can rely on it. If you can't, then you need to make sure that you're completely done before you opening the cabinet. So you cannot use this device if you can't verify the presence of voltage to start with. So disconnecting the wires in the industrial setting, I spoke to hundreds of customers how many times a wire got disconnected just because it got too tired by just holding off connected to a long time. Has it happened in your Charlie, have you seen that happen?
No. And here's the other thing, and this is why I mentioned this a while ago. It can be mounted on the door, and typically guarding is put on the wires that go to the main equipment, or the disconnect means wherever it is connected. But it can also be put on a non-movable part of the cabinet. Sometimes that's directly on the front, sometimes that's on the side or the top. It does not have to be mounted on a door that opens and closes. And this, if there's ever a concern that the wires would break or the wires would come off, then mount it on the top or side somewhere that it can be easily used. But don't worry about it's mount it where you are comfortable with mounting this device.
Sure. And the next one is when it comes to the new proposed language at each point of work, it seems like they're trying to address alternative energies with multiple power sources. I think absolutely correct. So that's one of the things I was thinking about as well. But to expand on that thought here, if you have multiple energies that's supplying the same panel, right? So if you have like a feeder coming from source A and another from source B, but both are coming to that panel, if A and B has been locked out and isolated, that's feeding to this panel, which is fed by these two sources, then there is no risk of having either of the sources feeding into that. Unless otherwise, if the second feeder is supplying any individual component, subcomponent within that panel inside that we can't isolate it from outside. Do you want to expand, Charlie, on that?
Well, yeah, so we've always had to address multiple voltage sources in equipment. That's part of regular 7E. That's part of these regular 7 or 8 steps. I don't know that it was originally submitted. I don't feel like it was originally submitted to address more than one voltage system coming into a cabinet. We've always had that. We absolutely do need to know what our voltages are coming into a cabinet. If it's 1, that's fine. If it's 2 or 3, whatever it is, that all needs to be part of these 7 or 8 steps to establish and verify an electrically safe work condition.
So Charlie, I think this is an interesting question. So testing for the absence of voltage on step 7 calls out for phase to phase and phase to ground, right? So what about testing the neutral conductor?
What about what?
Neutral conductor. If there's a 5-wire system with A, B, C, neutral and ground, why the neutral is not called out?
That's a good question.
That's a great question. Seriously, I'm thinking about it.
Really could say,
most of the things we see here is A, B, C, and ground. We don't see the 5-wire systems. Many cases.
Well, and this a qualified person would understand that. All right, we do have to test this, and I don't know. Should someone submit a proposal to change it to grounded or grounding conductor? I mean, that may be something that needs to be submitted. But yes, yeah. The neutral is grounded, but it may be back way back up the line or something. So
I mean, I had seen some instances way back in my experience, the hot neutral conductors as well. I mean, absolutely, yes. There is a risk of.
Yeah. So and again, part of this is being a qualified person to understand exactly what you're testing. I did a training in Oconomowoc, Wisconsin, a couple of years back. 30 minutes, and at one point I knew how to spell that. I don't know if I can spell it now. Oconomowoc, Wisconsin is 30 minutes west of Milwaukee.
Milwaukee, yeah. Close to Waukesha and Delafield.
We did hands-on training on a system that was a 3-phase Delta corner grounded system. And I've known about this forever from schooling, but I had never seen this system. Since then, I've shown a lot of pictures. I put them on LinkedIn. Evidently, Kansas City, Kansas has these systems around their area, but a corner grounded Delta system has a conductor that's on the neutral that had white tape on it, and it was a hot conductor, but it is also intentionally grounded. And so it's all of this it really comes back to the point, is someone a qualified person to work on this system? Do they know what voltages are coming into this cabinet, to this device? Do they know what they're testing for, phase to phase and phase to ground or phase to neutral? And so it's all of that should be part of being a qualified person, knowing what this particular system is.
Sure, I think we're on top of the hour, Charlie. I think we have 2 more questions. Probably you can respond to them or an email. I'll send it back to you. So again, thank you everyone for joining the webinar, and thanks for fielding the questions, Charlie. Please do take the exit survey as you exit the webinar. Your feedback is important for us. And also there are some other data sheets for download for safe test point and voltage indicators. Please feel free to download if you want to learn more about it. And again, reach out to our inside sales team if you want to see how we can improve electrical safety using our Grace permanent electrical safety devices. Thank you so much, Charlie. Thank you so much for your time again. Thank you, everyone. Have a great day.
Thank you.